Good morning, everyone. Today I will be presenting on the topic attention mechanism, one of the key concepts in modern deep learning. So let's go through it and understand how it actually works. So here, what is attention mechanism? Attention mechanism is a technique that allows models to focus on relevant parts of the input while generating each output. So our model is not going to work on each input. It's not going to understand each input. It's only going to focus on some keywords or some important words where the attention need to be paid. So the key idea is pay more attention to important words or features. Example, I went to the bank to deposit money. The model learns to focus on deposit money, means recognizing that bank is a financial institution, not a river bank. So the bank have two meanings, but according to context it will understand what it's saying, that it's a financial institution which deposits money. So it's inspired by human selective attention, because whenever we read something we don't process all the informations, we just focus on important information. So let's understand what is the concept of attention mechanism. The attention mechanism is a process that enables a neural network to dynamically focus on the most relevant parts of its input while generating an output. So it's a process that enables neural network to dynamically focus on the most relevant part of its input. As I discussed it earlier, unlike traditional sequence model that compares all input into a single context vector, attention provides a flexible weighted representation that changes for every output step. So here is a diagram which explains how it actually works. So at the bottom you see the inputs represents that input sequences, for example words in sentences x1 x2 x3 x3 x7 are the input words, which are the vectors. Memory layer, which is the context for each incoming time step. In this layer, think of this as the model's memory. Each circle contains contextual information about that token and its relationship to others. Attention model, which is a green box, this is where the attention computation happens. The model compares the current output query with all stored encoder hidden states to calculate alignment scores. The thickness of the lines is the attention weight. Like thick lines represents higher attention weight, thinner lines represents lower attention weight. Final layer is a decision layer, which represents the decoder's output state, the generation of the translated or predicted sequence. At each output step, the model uses the context vector weighted combination of encoder outputs to decide what the next word of the element should be. So this is the entire working of the attention mechanism. Let's go to the let's see the working mechanism. How does the attention mechanism work? So I have discussed already the diagram, but here are the steps that how it works computationally and mathematically. Each input is converted into a vector representation using an encoder, which can be RNN, LSTM or transformer. Step 2, we create three fields like query, key and value. For attention calculation, we define query queue, the current decoder step. What we are trying to predict now is a query. Keys, encoded representation of all input tokens. Value, same as the keys or derived from them, they contain the actual information to be passed to the output. So these are the three fields. From that fields, in step 3, we calculate score calculation, which is a mathematical method. The model measures the similarity between Q and each K. Means query and keys. Step 4, softmax normalization. The scores are converted into probabilities, means attention weights. Step 5, context vector calculation. The model computes a weighted sum of all value vectors. Step 6, output generation, which is the final step. The decoder combines the context vector, which is current state, to produce the next output sequence. Let's see the challenges. First, they are computationally expensive. Every token has to compare with each other token, which increases time complexity. Second, they use a lot of memory since all key value pairs must be stored. Third, attention weights are not always interpretable. High attention doesn't always mean true importance. Fourth, they require a lot of training data because it's too difficult on few data. So this is the challenges. Let's summarize what we have learned. The attention mechanism allows models to dynamically focus on relevant parts of input data. It assigns attention weights to determine how much each input contributes to the output. This concept forms the foundation of transformer models like BERT and GPT, which dominate modern AI today. So this was the attention mechanism. Thank you.